In this chapter, we're going to start talking about flow control, and specifically, we're going to be talking about different types of selection statements. Flow control is the idea that we're going to change the order that our code executes. So normally our code executes one line after another, and we've seen that in many examples. We execute line 1, then line 2, then line 3, then line 4, and that's the order we go in. A selection statement will allow us to skip some lines or run an alternate set of lines. And we'll see how that works as we get through the chapter. The first thing we need to talk about, though, is the Boolean data type. So a Boolean is a data type that can hold one of two values. It either holds a true value or a false value. Anytime you do some kind of comparison, you're going to get back a true or false. Or we can have a variable that we manually set to true or false. So the whole idea here is comparing two things together. And here's an example. 1 is greater than 2. Is that true or is that false? Well, we know 1 is not greater than 2, so this is a Boolean expression. And since it's a Boolean expression, it's going to compare the two numbers and evaluate it, in this case, as false. And then equals is our assignment operator. It's going to take that false value and assign it to this variable called b, which we declared to hold a Boolean value. That means b can only hold true or false. So 1 is greater than 2 is false. It evaluates to false. False gets stored in the Boolean variable b. And then we can access that variable when we need to access it. So let's talk about the different relational operators that we have. We have less than. These are all familiar to you from basic math. Less than. Let's go down this column here. Less than or equal to, greater than or equal to, and not equal to. Now, we don't have all these symbols available to us in Java. So Java operators look a little bit different when we type them. So less than just looks like less than. That's not a problem. Less than or equal to, we have to actually use a less than sign and an equal sign. Greater than is the same either way. Greater than or equal to, we use a greater than sign followed by an equal. And then here's the one that people forget that can cause some bugs sometimes. Equals. When we're using equals, remember I just said on the last slide, let me go back there, this was the assignment operator, right? We're going to compare these two, and equals assigns it to b. So if we want to compare two things to see if they're equal, we can't use the equal sign because the equal sign is already taken. We use it for the assignment operator. So instead of using just an equal sign, if we're going to compare two things to see if they're equal, we use a double equal sign. So anytime you're doing a comparison of two things, you need to use a double equal sign. Okay. And then not equal to, we use exclamation point or bang equals. That means not equal to. Anytime you see an exclamation point, it usually means not. That's a good way to think of that. So we can use any of these operators in our comparison. So I could take any of these operators and substitute them into here. I could say 1 equal to, that would be false, and it would store a false value. If I said 1 less than 2, that would be true, and it would store true in our Boolean variable b. All right, so let's take a look at a simple program that uses some Boolean variables. This example creates a program to let a first grader practice addition problems. The program randomly generates two single-digit numbers and stores them as number 1 and number 2, and then it displays a question like, hey, what's 7 plus 9? After the student types the answer, the program will display a message to indicate whether the answer is true or false. So let's look at the code for this. And here we go. I have a little demo class that I've rigged up here. And it's kind of interesting how we're picking the random numbers in this one because we're not using some of the methods, the random methods that are built into Java. We're actually looking at the current system time. So looking at your computer system and how many milliseconds have passed in this particular second. So there's 1,000 milliseconds in a second. And then we're using the modulus operator to divide that number by 10 and get the remainder. So we're always going to get, remember when we do modulus 10, we're going to get a remainder anywhere from 0 to 9. So ultimately, the current system time in milliseconds, when somebody says go to this program, that's a pseudo-random thing. Depending on when they said go, it's going to change the time, and we're talking 1,000 times a second, and it's going to get the last digit of the time, convert it to an int, and store it in this number 1. And this one's doing the same thing. Let's also get the time, the system time again in milliseconds. It may have only passed a few milliseconds here, and we don't always want our numbers to be that close. So this one actually divides the number of milliseconds by 10 and then takes modulus 10 to make sure we get two pretty distinctly different numbers. Kind of an innovative way to use the system clock, and it's used quite often to seed random numbers in programming. But we're taking the system clock, and depending on when the user hits the button, we're never going to get the exact same things out from one trial to another. It'd be very unlikely. All right, so we're generating a number from 0 to 9 and another number from 0 to 9. Then we're creating a scanner. We've seen that before. New scanner, system in, assigning it to this variable input that's of type scanner. So we can call for our input and ask it to get a number for us. Ask the user what is concatenating on the first number plus the second number. So we're asking the user to add those two numbers together, and then we have the scanner get the next integer. So the user types an integer in. So let's take a look down here. Before I show you this last line that prints it out, let's see what it prints. So it gets this 2 and 6 kind of randomly. What is 2 plus 6? And when I ran this, I put 9. And then it reprints the equation, or reprints the problem to the user. 2 plus 6 equals 9, and it says is false. So that could be a little more user-friendly. We could print out, hey, that's right or that's wrong, and we'll see how to do that in a little bit. But for now, we're just using the idea that we can generate a false or true by comparing two things. So if I run it again, what is 8 plus 0? If I say 8 plus 0 equals 8, that's true. Okay, so let's look at this print statement and how it works. We're printing out the first number, concatenating on a plus sign that we see here. We're printing out the second number, and then we're printing out equals, and then we're printing out the answer, okay, the answer that the user typed in. Then we print out the word is, we're concatenating that on, and then here's where the magic happens. We're taking number 1 plus number 2, adding them up, and on the other side of this comparison operator, we're comparing what the user typed in. So if number 1 and number 2, remember double equals is a comparison. If number 1 and number 2 equal, this Boolean, this entire Boolean expression is going to compare the right side to the left side. And if they're equal, it's going to print out true. If they are not equal, it's going to print out false. And that's how it's using a Boolean operator to compare to see if two things are equal, to give us either the word true or the word false. And that's what actually prints here when we print this. This Boolean expression here compares both sides, and since it's a Boolean, the answer is either true or false, and we can print that directly. Okay, I don't know if writing it directly like that is a great way to teach a second grader math, because it's a little odd. I think it'd be better to say, hey, that's not correct, or the correct answer is, or something like that. But it is a good demonstration of how to use a Boolean comparison and that it comes out as a true or false.